Hey guys, my name's Jason with Non-Baker Mining and Metals, and this here behind me is one of our complete 2-ton per hour turnkey systems for gold mining. And I want to take a minute to give you guys a full walkthrough of all the pieces, talk about how they work, some maintenance on them, show you how the whole thing starts, and at the end of the video we're going to run one as an example and show you how they work. The whole system is powered by this power plant. This is a 100 kilowatt Cummins generator powered with natural gas or propane. And it runs the entire system and has lots of power left over for other stuff such as pumps, lights, anything else you might need to power. Now let's go take a look at the jaw crusher module, and then I'll work our way down through the system and talk about each individual piece of equipment. Behind me here is the 8x12 jaw crusher module, and this is where the whole system starts. And the raw ore, the run-of-mine ore, gets dumped into this orange hopper here. The hopper has a vibrating motor on the back that vibrates the material down through the jaw crusher. The jaw crusher can take up to about a 7-inch rock. It'll crush that rock down to about 3/4 inch minus. It'll drop on this conveyor belt and flow up into the fine ore bin, which we'll take a look at here in a minute. The jaw crusher is run by a 10 horsepower 3-phase motor, and the vibrating motor and the conveyor belt motor are also 3-phase. The conveyor is 2 horsepower and the vibrating motor is about 1/3 of a horsepower. And again, this is all 480 volt 3-phase power. The module can easily crush 5 tons an hour or more, but we like to put the 8x12 module on our 2-ton per hour turnkey system so you have the capacity to crush a little bit larger ore. Let's go take a look in the hopper and I'll show you how the jaw crusher works, and then take a little bit closer look at the conveyor. Here's a look from above, looking down into the vibrating hopper for the jaw crusher module. And you can fill this hopper completely up. This will take about a half to 3/4 of a yard. And as it vibrates, the material flows down through that hole. So once the material drops off that little lip there, it goes right into the jaw crusher, and the jaw crusher will crush it down and feed it onto the conveyor. Here's a look at the motor. Again, this is a 10 horsepower 3-phase for the jaw crusher. Belts run up to the flywheel here on the jaw crusher. Now you're looking down at the swing jaw and right down there, down into the jaws of the jaw crusher. And through that little slot is the conveyor where everything drops out and gets fed up to the fine ore bin. The jaw crusher turns about 300 RPM. There's several grease fittings that need to be greased every day, every 8 hours of runtime. And I have some other videos on YouTube about how to adjust the jaws down here you can check out, and I'll leave a link to those in the description. The crushed material drops right out of the bottom of the jaw crusher and feeds up this conveyor here all the way up into our fine ore bin. Here's a look at the motor and gearbox for the conveyor. This is a 2 horsepower motor, feeds into this angled gearbox and runs the head pulley here. And it pulls the material right out from under the jaw crusher there and dumps it right in this fine ore bin. And the reason why we have the fine ore bin is so you can get surges through the jaw crusher. This will crush a lot faster than the hammer mill can take it, and so you need this secondary ore bin to evenly feed the material into the hammer mill. At the bottom there's a vibrating tray here that vibrates the material onto that conveyor, and it's run with a VFD so you can adjust the feed rate for the hammer mill. Here's that vibrating tray I talked about earlier. There's 2 vibrating motors on each side, and there's several adjustments you can make to this thing. One is this flap here. You can adjust closed or open for kind of rough adjustment. There's also some adjustment here on these wings for adjusting how much material can flow out onto the conveyor belt. And then again, the vibrating motors both are run with a VFD so you can adjust how aggressive they vibrate, and the more aggressive the shake, the faster the material flows through this vibrating tray. This second conveyor goes up here. It's an exact carbon copy of the one on the jaw crusher module. and this feeds up into the hopper of the hammer mill. And the hammer mill likes a nice, even, uniform feed, and that crushes the material down onto the shaker table, which also you want a nice, even feed and slurry for the shaker table. This is our 24x16 hammer mill. It's rated at 2 tons per hour, and that's with our smallest slotted screen, which is a 0.8 millimeter laser cut slot. The larger size you go, so we have a 1.2 millimeter, and you can actually get faster and more throughput through the hammer mill with a larger screen. The maximum feed size for this is 2 inches, but we recommend 1 inch and smaller for faster throughput through the hammer mill, and also the jaw crusher can do a lot more work a lot faster than the hammer mill can if you start feeding larger stuff into it. So having the jaw crusher reduce it to 1 inch minus and then feed into the hammer mill reduces wear on the hammer mill and also increases the throughput. On this system, we add about 2 to 3 US gallons per minute to the hammer mill to make a nice wet slurry that feeds right onto the shaker table. We add a little bit of water down the top, then we also add water here in the side of the case, here and on the other side, to help flush the material off the sides, keep it nice and clean, and run it down through the screen. With a 0.8 millimeter screen, the hammer mill will crush 50% passing 50 mesh and 30% passing 100 mesh at 2 tons per hour. If the ore is softer or more oxidized, you can get more throughput and a little bit finer crush. The screen size I just mentioned is for a nice, hard, competent quartz ore. Here's a look at the hammer mill from the back side. This is a 30 horsepower 3-phase motor, powers the hammer mill. Belts run from the pulley on the motor over to the shaft of the hammer mill, and the material comes from that conveyor, drops into the orange hopper and down through the hammer mill. Here are the hammers that we use for our ore application. These are a high chrome alloy steel, and in a 24x16 there's 24 hammers. Swing around and crush the ore. And these hammers, again, depending on the hardness of your ore, will last anywhere from 20 to over 100 tons. Here's an example of a 0.8 millimeter slot, and this is a smaller 16x12 screen, but you can see the size of the slot, and that wraps all the way underneath 180 degrees from the hammer mill, and anything that needs to come out of there has to go through this slot. So that gives you an example of how fine the material has to be before it can come out of that hammer mill. We always recommend getting at least 2 sets of extra hammers and 1 extra screen. And we also sell replacement armor for the inside of the hammer mill as well. And it's always nice to have spares on hand rather than wait for them to ship if you need them right away. Once the material is crushed down to the size it'll pass through the screen, it comes down here, the orange chute, in a nice slurry, and feeds into the aluminum distributor trough on the table. This is our 5x12 shaker table, and it's rated for 2 tons per hour. And once the slurry feeds down from the hammer mill into the distributor trough, there are adjustable gates here that you can adjust the flow of slurry onto the table. And the white water bars add water to the table to help keep everything fluid and moving. When the slurry reaches the grooves, the dense minerals settle down in the grooves, the gold, the sulfides settle down into the grooves and work their way across the table to the concentrate side, where any gangue minerals like quartz or calcite or any little bits of rock that don't have any value wash down over the grooves into the number 4 tailings. The tailings would be piped over to a spiral classifier, which we'll talk about here in just a minute. And all the heavy minerals, as I mentioned, work their way across, where the sulfides make a band going down into the number 3 middlings, and then the concentrates flow across into the number 1 and number 2. But let's go down and take a look at the concentrate end of the shaker table, and then we'll take a look at the spiral classifier. Once everything is settled into the grooves and it's working its way across the shaker table, it comes to a ramp, and we've built a ramp into the shaker table. It starts right about here and runs parallel with the end of these grooves, and the ramp starts uphill and ends just before the end of these 4 long grooves here. What that ramp does is it works the material across, but then any of the gang minerals, such as the quartz, can't climb that hill even in the grooves. So they make a nice straight line right at the base of that ramp down into the number 3 or the number 4, and there's a little aluminum splitter here that you can adjust that line with. Any other dense minerals like the sulfides work their way up the ramp in the groove, but as soon as they get out of the grooves, they can't go any farther up the hill, and so they work in a nice band right down here into the number 3 middlings. Some people save those for further refining. Some people have enough values that make it worth it. Other people, they just go into the tailings with everything else. It'll depend on your individual ore. The values, the gold and the other super dense stuff that you want to keep, is going to work its way up these 4 long grooves up onto this next flat, which we call the cleaning plane. Once the material is up here on the cleaning plane, you can adjust the water to fine-tune how much material works its way down into the number 1 concentrates. If you want more material there, then you can turn the water down. If you want to try and wash everything but just the very heaviest stuff, such as gold or copper, then you can turn the water up. Even if you wash some of the values down you want to keep, they're going to work their way down these grooves into what we call the 2 safety grooves, and they'll come over here into the number 2 concentrates. So you're not going to lose anything by maybe accidentally turning up the water too high. The table is actually really forgiving as far as value concentration. So you're just going to tune whether it goes into the number 1 or the number 2, but you're not going to wash anything into the number 3 because of these safety grooves. This shaker table uses about 15 US gallons per minute, give or take, depending on your water needs. To get the shaker table set up, it needs to be flat, level, parallel with the grooves, and tipped down towards the number 4 tailings trough at 1/4 inch per foot. And so when you get it all set up on this table, you have about an inch difference from the top to the bottom, 1.25 inches roughly, and it's, like I said, level this way in parallel with the grooves. So the water runs down towards the shaker table, number 3 and number 4, and the heavy materials work their way across the shaker table, up the ramp, and into the number 1 and the number 2. This shaker table is run by a 1 horsepower motor and is contained under this guard. There's a couple of grease zerks under there that you only need to grease about once a week. This is our spiral classifier and dewatering screw. And the way this machine works is you would pipe in your number 4 and maybe your number 3 if there's not enough values for you to save. And this box here is a basin that you create with water, and depending on how full the basin is, will determine the size of particle that sinks down and gets augured out of the system and dewatered. So the lowest setting creates a very small water basin, and only the largest particles, let's say 75 mesh and larger, will sink into the screw and get augured out. Everything else will go out into your tailings. There's a middle section and an upper section, and at this upper section, the basin is so large that only about 200 to 250 mesh and smaller discharge to the tailings pond with the water. All the other particles will sink down to the bottom and get augured up this screw and dewatered. Once the particles settle down into the bottom of this basin, they get augured up the chute here, and I don't know if I can get it. Yeah, I think, yeah, down the bottom. The screw doesn't actually touch the bottom of the chute, and that keeps it from wearing out. You make a sand bed down there so the material works its way up the screw on the sand bed and doesn't wear on the bottom of the chute. Once the particles get augured up this far, they're pretty much dewatered, and they come out this little slot, and you put a bin or a box bag, or you can just let them fall into a pile. But this is the oversize that if there's enough values here to recrush or save for later, you can save them and stockpile them. Or if you don't need to recrush them, they're at least dewatered and you haven't filled up your tailings pond with a bunch of of tailings that you need to dig out continuously, you can let the water recirculate a bunch more times. So this unit is actually really, really important if you either have to regrind your stuff to get it smaller, or if you just have to recirculate your water and you don't want to fill up your tailings pond. This unit is run with a 2 horsepower motor, just like our conveyors, and this is a really, really handy unit. It'll run up to 5 tons per hour dewatering. When starting up the system, the most important thing is to remember to start the hammer mill first, because it has the largest motor and puts the largest load on the generator on startup. So you want to get that started, and then all the other motors are fairly small. When I start up the system, I start the hammer mill first, and then I start things in reverse. Because if you start the hammer mill and the jaw crusher and you accidentally have some material or something starts going and flowing through the crusher and you don't have the rest of the system started, you're going to back up. Whereas if you start the hammer mill and then the spiral, the table, everything is working its way back through the system, and then you'll start the jaw crusher up last. So let me go start the generator, and I'll show you how to start up the equipment, and then I'll show you how everything works with ore in it. So to get the generator started, you press reset, and it'll come on with this screen. Give it a couple seconds, press manual, and then start. And the generator will come with a whole booklet of instructions on how to work it, and the owner's manual and everything like that. Just wanted to give you a real quick shot at how we start it, and then we'll go take a look at the electrical panel once the generator's going. So manual, then start. So a lot of people ask us about shipping, and we've shipped stuff all over the world. We have equipment in over 70 countries, and we can take this 2 ton per hour system and we can put it in a 40-foot container, so you have just one container shipping to your location. And once you get it, you can open it up, pull it out, get it set up, and be processing gold. So that's a nice rundown on our 2 ton per hour system. Now I'm going to pull some footage from our 1 ton per hour demo system and show you how each piece of equipment works running ore and recovering gold. So there's a good part of the gold out of the 1.5 or 2 tons that we ran. This gets brushed down out of the grooves of the table when we're all finished off, because it takes a while to build up in the grooves for it to be enough volume to sweep the gold out. So you always have to brush out what's left over after you're done running the ore. So we'll finish this off and tally it up. So we spread some of this gold out a little bit to see how it spreads out on the table when there's just gold. So everything on the left of this pile right here is on the downhill side of the ramp and is going back over under the water bar. And then there's some that we left on the downhill side of the ramp that's going to end up going down, getting caught in this long groove and coming out here and over to the number 1 high-grade hole. Alright guys, we got our concentrates here off the shaker table. There's our little bit of number 1 in there. And then here's our high grade number 2, so we got quite a bit more volume here. But most of our gold's in the number 1 here. So what I'm going to do is I'm going to pan this out, recover as much free gold as I can, and then I'm going to take the rest of the stuff, the panning tailings, and I'm going to smelt them down and see how much gold I lost in my panning. But this is a quick, easy, fast way to figure out how much gold you got if you're out testing tailings piles or dump piles or old ore dumps. And you don't necessarily want to go through all the trouble of smelting down all the concentrates and the number 1 and the number 2. You just want to get a good idea of how much gold is in there, and then you can get it weighed once you get it melted all down together into one big button. So that's the process I'll do now. We'll get this stuff panned out, and then I'll show you how I'm going to melt it all down into a button and refine it to get all the lead and copper and other junk out of there. All right, so I got our gold panned out here, and the lighting's not great, but there's our gold. And now I'm going to take just a little snuffer bottle and get it all sucked up, and then we'll strain it through a cloth and wring the water out, and then we'll melt it all down into a little button. Okay, now I've got our snuffer bottle here. I don't know if you can see. I can chase this gold around, but there's gold in the bottom there. It's hard to see. But anyway, we got all our gold sucked up in our snuffer bottle there. And now I'm going to take the gold and put it in this rag. It's just a blue shop rag. I got a cup underneath. I'm going to take out the straw here. And if you guys have watched my other videos, you've probably seen me do this before. I actually discovered this by accident. You can see the gold coming out of there. When I wanted to try and clean up my gold here, I was going to try and Q-pel it, which is mixing it with lead after you've smelted it and everything. And I had a bunch of gold, and it was almost clean, and I didn't want to smelt it because that just takes a long time, and not a long time, but it's a little bit of a hassle and a little bit of an extra step and stuff. And so I tried just direct Q-pelling it. I cleaned it up as best I could, got it in this rag, and Q-pelled it, and ended up with a really nice little gold button. And so I've since taken up to doing this whenever I'm kind of in a hurry or want to get a quick result and I don't have time to smelt. And I also like to pass this stuff on to you guys. So I've got most of my gold out of there. I'm going to save that. Obviously, I won't just dump it out. There's still just a little bit of gold in there, but here's our, let's see if I can get her focused here. Here's our gold in our rag. And now I'm going to take our rag, pull it up, and I'm just going to wring the water out of this rag. And all the gold is going to stay down here in the bottom in our little, oh, it ripped. All right, plan B. I'm not going to be able to get as much water out as I hoped. Okay, don't rip it. In the future, don't rip it. What I'm going to do now, I'm just going to cut it off here. I'm going to put this in our cupel. It's in the furnace. It's hot. And it'll evaporate all the water off. It'll burn the rag. And it'll leave our gold all dried out in the cupel. So there you go. Mount Baker Mining and Metals bloopers right here. All right, guys, here's our little gold button. Let's see if I can get it to focus here. And there you go. It might be hard to tell in the video, but it's pretty shiny yellow, so there's not a whole lot of silver in there. And it's got those kind of cooling lines on the surface. So there you go. Not bad for a couple hours of running this morning. Let me get the scale out. We'll see how much it weighs. All right, here's our gold. The stuff I panned out ends up weighing about 19.25 grams. And those bags are somewhere probably around 1.5 tons, maybe 2 tons. So we're somewhere in the range of 10 to 15 grams a ton with that stuff. And that's stuff I could pan out. Now let's go and smelt the stuff I panned out, and then we'll also smelt some number 2 and see how much precious metal we have in there. All right, here's our number 1 panning concentrates. I left them in the frying pan last night, let them dry out. And now we're gonna roast them. I'll heat them up to about, 800 or 1,000 degrees Fahrenheit for about 10 minutes and get them roasted, drive off all that sulfur, and then we'll smelt them. All right, so we got our lead button here, knocked it off the bottom of our slag. I'm going to put it in one of these cupels, and I'm going to put it in our little electric furnace and drive off the lead and see what kind of precious metal button we got left. All right, guys, so we've done all our experiments, all our smelting and stuff, and wanted to let you guys know how much gold I actually recovered. So here's the stuff that I panned out. That's that 19 1/4 or so grams. This little button is the stuff that came out of the number 1 panning tailings, the stuff that I panned out. That's the gold that I lost. And I smelted it down and got a little button out of there. So altogether in the number 1, we ended up with about 21 1/3 grams. And then I took some of the number 2 high grade that we had and smelted 300 grams of the number 2 and ended up with this little tiny bead here, which weighs right around 1/10 of a gram. And I've dried out and weighed the rest of the number 2 concentrates, and I have about 3 kilograms of that stuff. So multiplying this number by 10, which I have about 10 times as much left, there's about a gram left or so in the number 2 high grade. That being said, it's not probably practical to smelt down 3 kilograms worth of stuff to get 1 gram of gold. It's just, it takes too much energy and flux and time and all that stuff. But I wanted to share with you the end result from running our 2 sacks of stuff through our 1 ton per hour turnkey system. We ended up with right around that 10 to 15 grams a ton, even when it was all cleaned up and smelted down. So I think that was a pretty successful run. These guys were able to crush a full hopper for the conveyor module in about 25 minutes of runtime with the jaw crusher. And the conveyor module hopper can hold about 1 cubic yard, but they overfill the hopper. And so in this situation, it's probably holding somewhere between 2 and 2.5 tons. And so when the hopper was full, they would shut the jaw crusher off. And then it took the hammer mill about an hour to process the hopper. So the jaw crusher was only running part of the time for this operation. One of the things that was very unique about this mine is their gold is very, very coarse. And so unlike most mines that want to crush as fine as possible, these guys actually had a screen that was fairly large. And so in some of the shaker table videos, you may be able to see some larger pieces on the shaker table. And the reason they wanted to crush the material fairly large is so that the gold didn't hang up in the hammer mill and get over processed or grind up. And so these guys' goal is to process the tailings through a spiral classifier, as you can see here, auger out the oversized quartz, and then recrush at a later date to liberate more gold. But because a lot of their gold is so coarse, they have to do a coarse crush and concentrate first, and then they can come back later and capture the fine gold once it's recrushed again through the hammer mill with a finer screen. And here you can clearly see the large quartz pieces on the shaker table. But again, when we look into the number one trough here, you can see the large pieces of gold that they want to get out of the grinding system as soon as possible. So here's some gold from our cleanup from last night, and we ran about 2 tons, and this is probably half of the gold. They're cleaning up the rest here now, but you can see the gold is very, very coarse, very big pieces, and hardly any fine gold. It's just mostly big pieces of gold, and this ore has very little sulfides, so it's mostly just quartz and big gold, which is pretty unique. All right, guys, we've finished our run. It took us about an hour and 10 minutes to run that whole bag. I figured it was about a ton or maybe a little more. And so that pencils through our 1 ton per hour turnkey system here. And the table's pretty much cleaned itself off. I wanted to show you here up close. Here's the top 3 grooves. And the gold just piles up in those 3 grooves. And when it comes across, it gets into this long groove up the cleaning plane and up under the water bar. Some of the gold gets past. There's a little bit here, a little bit there. But then once it gets down here, you don't see hardly any gold in any of the grooves. Here's a second long groove up under the cleaning plane. But by the time you get down here, all the gold's gone. By the time you get down here, all the gold's gone. It's pretty much all working its way up. Some of it comes down here and just cascades down along the long grooves. But you can see here it makes a sweep right down in here into the number 1. And then the bigger, the larger gold comes down here under the water bar and just makes a, see the sun's right, makes a pile. Because most of it's washed down now, but there you can see there's a little bit of pile left over from the water dripping. And so now what I gotta do is I gotta brush the table down. I'll turn it back on and I'll just brush out all the grooves, brush everything down this way, down into the number 1 and number 2, and then we'll pan it out and we'll recover our gold. All right, guys, here's our 2 buckets. There's the number 1, which doesn't even have a pound of stuff in it. And a lot of that stuff you see in there is stuff that came down when I brushed down the table. And here's the number 2. There's probably 2 or 3 pounds in there. Mostly black sand. There's very, very little gold in here. I may pan it out, but most of our gold's going to be in here. So let's go pan these out, and we'll get our gold refined and melted down into a little button. All right, guys, here's our concentrates in a pan. I'll get these panned down, but you can see, I'll just give them a little swirl. Oops. You can see the gold in the corner there. There we go. There it's kind of showing up. So let me get it cleaned up a little bit, but we got a pretty nice little gold line in there. All right, guys, well, here's our gold. And it's a little hard to see against the gold pan, but there's most of our gold right here. There's some that's come down. There's some of the bigger pieces that got washed down there, but there's a majority of it. So now we'll get it cleaned up and melted down into a little button. All right, guys, so we got this is our number 1 pan down. I am going to get this cleaned up, and I'm going to show you what I'm going to do here. I got to get the gold exposed a little bit better, but I'm going to suck it up with a snuffer bottle. And then once it's all sucked up in the bottom of the snuffer bottle, I'm going to try and not get much black sand. I'm going to try and keep it mostly gold. But if I get a little bit, that's okay. And I'll get it in the snuffer bottle. And then once I have it full in the snuffer bottle, I'm going to filter the water out through this shop towel. And it's just sitting in a little cup here. And we'll get our very high-grade gold concentrates with a little bit of black sand and base metals. There's a little bit of copper and stuff in there. But we'll get her in here. And then I'm going to nip that off, and I'll show you how I refine it from there. All right, guys, so I got my snuffer bottle here. Just going to suck up the gold. And like I said earlier, I can get a little bit of black sand or sulfides. Those will oxidize away, but I can't get too many, or it forms an oxide film on top of the cupel here, and I'll show you that in a minute, how that works. But I just got to work the gold out of here, get it as clean as I can. All right, so we got most of our gold in here. I just take the straw out here. Careful not to lose anything. And then I take my thumb or my finger, shake all the gold down to the bottom. I just drip it in the in the shop towel there. And we're just trying to get it as dry as we can. There we go. There's still some in the gold pan I got to get, but you can see our little pile of gold down there. So we'll get it cleaned up and get that wrung out, and then I'll show you how I use this little cupel here and refine our gold. All right, so I'm just going to take our towel here. I've got our little, there we go, got our little gold in the bottom, and I'm going to wring out as much water as we can. I'm going to put this in a really hot furnace, and we don't want a lot of water in there with it. So now we've got our little gold sack there at the bottom. Just cut that off. Doesn't work very good with tin snips. Now what I'm going to do is I'm going to take this cupel, I'm going to put it in the furnace, get it up to temperature about 1750 degrees. Then I'm going to take our little gold sack here, put it in that hot cupel. All the paper is going to burn off, and the gold's going to be left. And then in the past I've done lead, but this time I'm going to do something different. I'm going to use bismuth as the refining metal. And bismuth is pretty cool because it has a lot of the same properties as lead. It has about the same melting point, about the same melting point for the oxide, but it's not nearly as toxic to humans in the environment. So I'm going to start using bismuth for this process. It's more expensive than lead. It's about 3 times as much, but in this thing here, I have 2 pounds of bismuth, 2.5 pounds something. Bought it on eBay or Amazon or something. And this will last me forever. I think it cost, I don't know, $25 or something. It was about $10 a pound, which is, you have to pay quite a bit when you buy it in small amounts. But for something like this, I would use a piece of bismuth, like probably about this big. When you're doing your refining like this, you try and use, I don't know, roughly half gold to half oxidizing base metal. So if there's, I don't know, I'm guessing here, but if you have, for example, 5 grams of gold in here, use about 5 to 10 grams of bismuth. And, if your button doesn't come out nice and shiny gold, just add another 10 grams of bismuth and keep cupelling until that button comes out shiny gold in your cupel. And that's when you'll know all the base metals are off of it. So let's go put this in the furnace, and we'll see how we go here getting this thing refined. All right, guys, so I just got our little gold packet in there, and the bismuth is melted now. I couldn't do everything all at once, so I had to put it in and then show you the video. But we'll get that cupelling away and see how much gold we got. The one we're doing is in the left one here. This is something else. I'm trying to use my furnace efficiently. When I got it going, I try and do a bunch of different stuff. So yeah, we'll check back on this one on the left in a little bit and see how much gold we got out of our 1 ton of material. All right, guys, here's our nice shiny little bead. There's a little bit of junk on it. That'll chip right off. But it came out, turned out nice and yellow, and we'll get her cleaned up here a little bit and get her on the scale. All right, here's our button. Get her on the scale here. See how much gold we have in our 1 ton sample we ran. About 9 grams almost. So right about 1/3 of an ounce. All right, guys, well, thanks for watching our video. I hope you enjoyed it. If you have any questions or comments, you can find our email or phone number down in the description below. And if you have any interest in any of this equipment, we sell everything you saw here today. So give us a call and we can hook you up with pricing and more information. So thanks for watching, and we'll see you on the next video.